Good morning, all. Well, good afternoon in South Africa. I don't know where the rest of you may be. Maybe if you can just type it into the chat box. But thank you all for joining us for today's webinar. My name is Kumo, and I am a course advisor in our South African offices in Johannesburg. And today, our webinar will be presented by Dr. Namli. So if you can please just take a look at the instructions in front of you, please turn off any notifications just to avoid disturbances during the webinar, and you can turn them back on after this. So when it comes to the questions, we do have a Q&A chat box. You can type in your questions there, and myself or Dr. Namli will be able to answer your questions. So with no further ado, we can get started. And at the end of this webinar, you will get a copy of the slides as well as a certificate of attendance. So at the end of the webinar, there will be instructions as to how to obtain the certificate of attendance, as well as the slides and the video recording of this webinar. So please stay up until the end of the webinar to receive that information. So just to give you a little bit of a background about EIT. So EIT is an engineering specialist institution with industry-orientated programs that offer world-class Australia accredited education. And this is all thanks to our industry experienced lecturers and our unique delivery model. So this is exactly why we say this, because we are the #1 Australian provider for students' overall satisfaction in postgraduate engineering programs. And then we are also #1 Australia's provider for graduates in full-time employment, as well as top 3 for providers of quality education, as well as top 3 Australia's provider for student support for postgraduate engineering programs. So this is echoed by the awards we received last year in 2024, and that's for the Export Award for International Education and Training, as well as for West Australia. So today's topic is going to be concrete admixtures, life cycle assessment, and avoided emissions. Like I said, it will be presented by our lecturer, which is Dr. Namli. So with no further ado, Dr. Namli, could you please go ahead and introduce yourself and get started with the webinar? Thank you all for joining.
Yeah, Kumo, thank you very much for your introduction. Welcome everyone to the webinar today. Good morning, good afternoon, and good evening. Yeah, my name is Nam. Today I'm very excited to going to present or to share my understanding for the concrete admixtures with the life cycle assessment and also the avoided emissions of this material, of these type of materials. Very quick about me. I work for a concrete company. I also work for currently with Sika Australia with technical roles in technical service and for product management, and also currently with R&D sustainability. I'm very interested in sustainable material solutions and also initiatives for reducing carbon emissions of concrete in general. Right. And for today's webinar, I'm going to share firstly the general understanding on concrete admixtures, Secondly, will be general understanding for LCA and EPD, mean life cycle assessment and also environmental product declaration. Next will be 2 case studies. One is for EPD, in specifically for the results of life cycle assessment of admixtures. When we here in Australia, we have several admixtures having the EPD recently, last year and this year. And last will be another study, a case study, when I share about the avoided admission with concrete admixtures and how admixtures can create kind of avoided admissions. Right? Okay, firstly, for concrete admixtures, admixtures is, and as a term, what it is, the admixture means in Oxford's dictionary, it is like a small amount of something mixed with something else. And the AD here is like a prefix from Latin, mean to or towards. It means we have something we add to the other things, right? And what we add to is the concrete, right? We have concrete. I just have a very simple graph here with like typical compositions of concrete. We have most of the weight is the aggregate, like quartz aggregate or fine aggregate, and fine aggregate means sand, right? And then we have cementitious materials. Nowadays, it will be, of course, with cement and also with other SCM, means supplementary cementitious materials. And next, of course, we need water to have all the reaction of this one, and admixtures will be something to add in that one, right? And typical doses for admixtures, how they quantify the amount of admixtures. Normally, they have the quantity by the doses of around 300 minimum, at least we have seen, and up to around 2000 millimeters per 100 kg of cementitious material. What does it mean? It means we quantify the admixture amount based on the cementitious materials, right? Let me pick the laser point. Sorry. Okay. Okay, and then if we take the weight of the admixtures and we compare with the weight, total weight of the concrete, it can be very small amount, very small, just around 0.03 up to 0.2% by weight of the concrete, right? Saying that admixtures is very small amount, and what can be the draw of this one, right? Draw of the admixtures, we can have different rows and with, or in other words, different types of admixtures, right? Based on Australian standard IS 1478.1, we have different types. The most popular one, I would say, is the all-range water reducing admixtures, including the water reducing admixture, WR. MWR means medium range water reducing admixture. HWR meaning high range water reducing admixtures. And minimum reducing the percentage of reducing water is 5%. What we know is when we can reduce the water amount, we can reduce the water to cement ratio, right? And that one will help to increase the strength of the concrete, right? This is the main purpose of these admixtures, right? And with different classes, different grades, we have different levels, right? Next one is retarding admixtures when we want to extend the set time of the concrete so that we have more time to work with, right? And minimum requirement is we retard the set time of 1 hour, right? Accelerating admixture is what can help to shorten the set time of concrete at least 1 hour, right? Of course, we can reduce more, but at least 1 hour reduction in the set time, right? And special admixtures, nowadays we have more and more types of special admixtures. One of them is to keep the slump of the concrete. For example, we want to have not only the longer set time, but also we want to have good workability. The slump is detained or maintained for longer time, and then we can have this type of admixture. We have other admixtures to reduce shrinkage. Some admixtures can help reduce the corrosion of steel bars, etc. Many types of admixtures, right? And we have air entraining admixtures when we want to introduce air entrainment to the concrete, right? And also we can have some combination of different types, and then we have additional ones. Like here we have water reducing and retention. It means we have retarding effect and water reducing effect, and then we have this type of admixtures. We can also have accelerating effect and water reducing effect, and then we can have this type of admixtures when we have both two effects, right? Water reducing and accelerating. And if we have the special one, we can also have like retarding admixtures together with other type of other function we have for the special one, and so far and so on, right? It can be seen here that we have many types with different functions, so that we can have for certain application, like in the hot weather, we may want to have something like we want to have retarding to extend the set time so that we can have enough time to work on the site. Or sometimes like in the winter time, it's too cold, and then we need something to accelerate the hydration of the concrete, so that we can use the accelerating admixture, right? This that one is very generic about the types of admixtures. And imagine what happened for the modern concrete industry if we don't have any admixtures, right? Just some examples here for us to think. Is the first aspect is the workability. Imagine if we don't have admixtures, and then when we produce concrete, especially the high strength one, and concrete will be very harsh, very difficult to mix, right? Because you have very low water amount, and so that very high cement and very low water, and then concrete is very sticky, very harsh, right? But with the admixtures, we can help to like still maintain the low water to cement ratio, but the workability is better. Concrete is easier to work with, right? Workability retention. If we don't have admixtures, especially imagine like what we have previously, we only have some water reducing admixtures, we have accelerating admixture, but we don't have any special admixtures, and then we can reduce water, but after some time, the slump of concrete lost, right? It dropped very fast, like especially in the hot weather, and then you cannot control it. And imagine if you have a concrete truck and we have traffic jam, and then without the admixtures, concrete will die in the concrete truck, right? And then we cannot use when the truck arrives at the site. That's why admixture is very important here. Strength, yes, we can reduce the water to obtain high strength, but without admixture, that one is very difficult to obtain. Setting time, without admixture, we cannot control easily like what we have now, right? Because especially with different temperature of the different conditions, right? Efficiency, if you simply have cement, if you only have aggregate and water, you will have very low efficiencies formulation of the or misdesign of the concrete, right? When we can introduce admixtures here, we can reduce the cementitures, we can include different type of cementitures, so that we can optimize the misdesign, and then we can reduce the total cost. Also, reduce the emission or the environmental impact of the country. Yeah, this is for the like kind of the how the admixtures play the role in the modern concrete industry. Hopefully it's clear enough for the like very general understanding for concrete admixtures. If you have any questions, feel free to put in the Q&A section, and then we can come back to answer later. Thank you. Second part, we will try to understand a bit for the LCA and EPD, right? Okay, LCA. LCA, I think this term had been for a long time, but more nowadays is like widely mentioned, right? I could say life cycle assessment. This is the standardized method. People describe the circle of the product with the assessment of that one. For example, here we have a product, right? Like in this case, we have concrete admixtures. And where is it from? That admixtures will come from all the natural resources. We have all the materials from different sources, right? But all of them will come to the factory. They are all the raw materials come to the factory with all the transport, and then they are produced in the factory, and then they are transported to the site for the application. And then after that, 50 years later or 100 years later, the concrete is disposed, and then the admixtures also disposed in the same time because it's in the concrete, right? And it comes to the end of life of the product, and it becomes like waste, right? This is the cycle of the product, and the life cycle assessment will check every step in this circle to see how many kg CO2 or how many gas or greenhouse gas, other greenhouse gas released to the environment because of these processes, right? And to conduct this study, life cycle assessments like a study, right? To conduct this study, people need to have like a database. They have the modeling software so that they can collect all the data, and then they can analyze, and then they have the results. Final results will be how these products affect the environment in terms of environmental impacts like greenhouse gases or other impacts, right? And the results of the LCA, the life cycle assessment, will be reflected in the EPD. EPD meaning environmental product declaration. Nowadays, if you are in the construction industry, and then you will be heard a lot about this EPD. Like every site, especially the big projects, they always ask the supplier, do you have EPD for your product, right? And this EPD will need to follow certain standards, and one of the most important or widely accepted standard nowadays is the EN 15804. And then many construction products need to have the published EPD with this kind of standard. Figure 3 here shows just an example, just the cover page, of course, of the EPD published by EFCA. It means the association in Europe for concrete admixtures. This is more or less like the earliest EPD of admixtures published for until now, right? This is the earliest one, right? And also the most widely recognized one, because not many companies publish it, but and also not many products have the EPD. That's why when they don't have like the contractors, they don't have any information, they need to get this EPD to assume that this is their for their products, right? Okay, and what contents we have in the EPDs, or in other words, the LCA results, how they are reflected in the EPD. If you see the screen here, I just have a screenshot for one table of the inside the EPD, right? In the EPD here, in this document, you can see here, we have different stages. And the most important thing of a product is the product stage. It means that product will come from whatever materials from the from all the resources. They come to this one and they are produced here, and this come to the stage of product stage, or sometimes people call it a production stage, right? But it's not really only the production, not only in your plant, but not only in your factory, but also include all other things before that, right? From the original materials, right? And after the products are produced, we have all the environmental impacts from A1 to A3, and they call it the cradle to gate, right? To gate here means your factory gate. Out of the factory gate will be next stage. Before the gate, before your factory gate will be this stage will be the cradle to gate stage, right? And after this one, your products will move to the next stage of applications when it is transported to the site, and you have the A4 here is the module when you transport the product, and A5 will be the assembly at the site, and use stage meaning all the like environmental impacts your product have during the usage of the product at the site. For concrete admixtures, you can see here from the EPD of Europe, either they don't, either is not relevant or is not declared in this use stage, right? Because the admixtures will be mixed in the concrete, right? And then concrete we have its use stage not really relevant to admixture. Admixture, in other words, admixture mostly don't have anything during the use stage, right? Okay, and then end of life of stage is when the concrete together with the admixtures inside will be disposed or will be sent to the landfill, and then we also have all the processes like transport or treating the waste at the or disposal, right? And then also there are some benefits beyond the system. D here, the module here, D here, when sometimes concrete is recycled back and to make like either the aggregate or to be the backfill somewhere, right? And yeah, it means that for this EPD, for the EPD, you will have all the modules here, all the stages of your product to check, to analyze, to study, and see how much, for example, CO2 released from this stage, right? And the results here typically calculated for 1 kg of product like admixtures. People also calculate it for 1 kg of admixtures. Okay, and it comes to the question earlier that the admixtures amount is very small in the concrete. Why are we interested in the LCA or the life cycle assessment of admixtures, right? Just some figures here for you to understanding the whole picture. Like global admixture market, we have like quite huge market with the total values of 19 billion US dollars in 2022. according to this report, right? And it means that with these values of the market, it means that we have million tons of admixtures produced every year, okay? And also, if we have only in Australia market and we only focus on the concrete market, only in Australia, we have 29 million cubic meter of concrete is produced every year. The values, the figures here from I think 2022 or 2024, but published again in the website in 2025. And then with this amount of the concrete, it means only in Australia we need at least 40,000 or up to more than 100,000 metric tons of admixtures, right? It means within Australia, we also produce a lot of admixtures for concrete. And with the amount metric tons of admixtures produced, not only Australia, but globally, it means we also release a lot of greenhouse gas, right? We also have a lot of emissions to the environment. We release a lot to the environment. And what happened? These greenhouse gases will cause the like warming, will make the earth more warmer, right? That's one is the fact. Everyone, every manufacturer need to be aware about that. We are producing, it means we are releasing the greenhouse gas, right? The problem is, the thing is how to minimize this one, because we cannot avoid producing. We must produce to improve, to build, or to have the economy developing, right? But we need to know, we need to think how to minimize the environmental impacts, how to minimize the negative thing, right? And one of the things is we need to have the EPDs. We need to publish the transparent information about the product with EPDs. And that's the reason why we have like increasing numbers of EPDs published, like not only Australia, but all around the world. And if you can see here in the graph, we can see initially we have some EPDs published by the Association of Admixtures in Europe here. And then after that, 2023, we have some more also from this association. And 2024, we have many more from not only Europe, but also here in Australia. We have many admixtures published EPD, right? And we also have some EPDs for admixtures published from Asia and from North America, right? And the number will be increasing more, right? And if you can see in the figure 5 here, different types of admixtures are published. Of course, the most widely used admixtures is the water reducing admixture. It can be the low range, it can be the mid range, it can be the high range water reducing admixtures, right? More than half this type of admixtures. We also have other type of admixtures published EPD with like set accelerating admixture or retarding admixtures, right? And yeah, it means different types of admixtures already have the EPDs, right? And the number of them will be increasing. Okay. And here I just want to introduce some types of the EPDs we have, not only for admixtures, but all other products. Typically, we have specific EPD, average EPD, and model EPD. Specific EPD is when the EPD is for only one product, right? And we have only one product here, right? And specific EPD is normally in one country only, and the environment impact will be the specific one. Like here, right? We have one product, one admixtures. It can be produced in different factories of the same company, but only one product. And the environmental impacts of this product will be very specific, right? This one is only for this product, right? The results, I mean the CO2, right, will be very specific one, right? The next one will be the average EPD. Average EPD meaning we have different types of or different products, many products, right? And when we have different products, it can be produced in different factories or the sites, and then we need to have the average one, right? It means the results, meaning, for example, the CO2, the quantity of CO2 of 1 kg of products will be the average one, right? Somewhere average here, right? And model EPDs is also when we have many products, but we don't take the average of this one, right? We take the highest one. And this is the case of the model EPD in Europe, when they have many countries, they have many factories, and they only calculate, they estimate so that, okay, I select the highest value of the CO2 of these admixtures, right? And then all the admixtures here, the environmental impact will be either similar or smaller than this value, right? And yeah, in other words, the environmental impact of this one will be the highest one, right? Okay, and how to obtain the EPD or how to publish the EPD? We need to have different steps. We need to have the data collection. This one is a very hard one. We need to collect the data of the formulation, of the transport, like where we get the raw material from, and production, like how many kilowatt hours of electricity we use to produce 1 kg of the product. And other information like packaging or other assumption we need to make to collect the data and to calculate the LCA's results, right? And the next step will be conducting the LCA study. We need to have a modeling. We have software to get all the data in, and then use the software to calculate. And then the next step will be the verification, when all the results of this modeling will be sent to like a third party, so that people can check and review and see, okay, is it okay? It is reasonable. The methodology is okay, or the results are okay, or it need to be revised, kind of that thing, right? And after you have passed the verification, and then you can publish the EPD. It can be with different operators like International EPD from Sweden, or IBU from Germany, or ASTM from the United States. Right? We have different EPD operator or publisher, and then they need to assign the verification, the verifier, and they after the verifier agree with all the things, and then they will publish the EPD. Right? Okay, some common misunderstanding for EPD will be, first one, our admixtures having the EPDs will be more sustainable than those without EPDs. That one is not true, or in other words, it's not always true. The reason is, if you, as just now mentioned, when you have a product and we don't have the EPD, right? We may assume that this one is the model. We need to take the model EPD to assume for the like how much of the the CO2 of this product is, right? And then that case, we need to select the highest value of the environmental impacts. But if we have the EPD, and especially if we have the specific EPD, we will have like exactly how much how many kg of CO2 relevant to this product, right? That's one not really more sustainable, but more transparent, right? I calculate and I know that this product 1 kg will be this how many kg of CO2, right? Secondly, are low emission admixtures always necessary to achieve low emission concrete? This one is not really also. The reason is, as you can see here, the admixtures accounts for a very small percentage of the concrete, right? And when we have low or high emissions of these admixtures, it's likely that you don't affect much the total emission of this concrete, right? But these admixtures can be used for like concrete company A, concrete company B, or concrete company D, or whatever, right? And if I sum up all the admixtures I sell to these companies, the total amount of admixtures, of course, will be huge. That's why the low emission admixtures, although it doesn't affect much the total emission of the concrete, but as a manufacturer of the concrete, we need to publish the EPD to because it's relevant to many, not only this company, right? And it's for the whole industry of the admixtures, right? Number 3, are EPDs from different programs always comparable? That one is normally not always also. They can be comparable only like under specific conditions. For example, company A, they publish EPD with IBU. Company B, they publish with international EPD. If these two EPDs, they follow the same standard, yes, they can be compared, but they publish different standards, and then it's difficult to compare, right? That's why it's not always comparable when we check the EPDs, right? Okay, let's move to the next sections, like a case study for the results on the life cycle assessment of admixtures. Very quick about this one, we have the EPD published by Association of Admixtures in Europe, and in this case study, I just analyzed the water reducing or the plasticizer of this association. They published in 2021 and 2024, right? And in 2021, with this type of admixtures, they published only one EPD, model EPD. And then in 2024, they published with 3 EPD. And last year also in 2024, SICA Australia also published several EPDs. And for this water reducing admixtures, we published 9 EPDs, right? And these 9 EPDs will be covered in this case study. Very also quick about Association of Admixtures in Europe. They have different members from Germany, from France, from Italy, Finland, right? And here the EPDs published by SICA Australia cover for different sites in Australia. And here we only analyze the results for the global warming potential. What I just now often mentioned is the CO2 of how many kg of CO2 relevant to 1 kg of product. And as you can see here, the red dot or red symbol here for the admixtures of specific EPDs published by SICA Australia. We have WR and WRRE, meaning the water reducing, like the low range of water reducing admixtures. And MWR here is the middle range. We can have a little bit, we can see the value of CO2 a little bit higher here. And HWR meaning the high range water reducing admixtures. You can see that the GWP or the global warming potential of these admixtures is a bit higher, the highest one in this group. And we also have here SN, special admixtures, and the GWP, or the global warming potential, is a bit lower than the highest one here. And if we compare with the EPD published by Europe, we can see this is the EPD published in 2021. The value is super high, very far away from all the admixtures we have, right? In 2024, they published 3 types of admixtures. One is the mid-range. You can see here is slightly higher than the one in Australia. The middle range is also a bit higher than the middle range in Australia, and the high range more or less like quite similar to the high range in Australia, right? And as we know, the model EPDs generally provide like highest value of global warming potential than specific one, right? But from this graph, we can also see that admixtures with higher like reaction, like more reaction or more reactivity, will be like with higher global warming potential, right? But it doesn't mean that we should not use the high range one, right? Because when we use the high range one, we can use like lower doses, and it's not necessary like higher environment impact for the concrete. But for the product itself, it can have higher one, right? Yeah, and then we can now move to the next case study for the avoided admissions with admixtures. What is avoided admissions? This concept is when we have the difference of like the greenhouse gas emission between 2 scenarios. The first scenario is as usual. It means, for example, for the concrete, we have the normal concrete, we have the normal admixtures, normal cementitures. And the next scenario is when we have new admixtures, new solution, and then we can have lower emissions of the concrete. And the difference between these scenarios will be the avoided emission. It means we can have reduced the emissions of the concrete by a solution. And this avoided emissions, sometimes it is referred to as the scope 4. And what is scope 4? Why we have the scope 4? Because we have previously will be scope 1, 2, 3. And what is scope 1, 2, and 3? I have here very quick introduction about this one. For example, we have admixtures, right? Admixtures, we have the life cycle assessment of admixture here. And then we can see that, okay, to produce these admixtures, we need to have the electricity, we need to have the fuel, and we have all the raw materials, all the transport. All these things will be reflected in scope 1, 2, and 3 of the manufacturer's inventory. It means that as a admixtures manufacturer, the company need to account or need to responsible for all the scope 1, 2, 3 they are with. Like here, we have scope 1 is all the fuels we burned in the factory. Nowadays, we don't burn much in the factory, of course, especially like concrete admixtures manufacturer, they don't burn much fuel, right? But maybe it can be just a little bit of gas, or even the vehicle, the company vehicle, like the car we drive, if that one belongs to the company, and then we need to account for that fuel we burned with that car, right? And scope 2 is all the indirect use of electricity. When, of course, we need to use electricity a lot, and the emission relevant to electricity will be reflected in scope 2. And scope 3 is all other things like the raw materials, all the services we have. For admixtures manufacturing, typically scope 3 will be the biggest one. It means we have all the things from other parties, and what we can control is scope 1 and scope 2. What we can control directly is scope 1 and scope 2, like we use less fuels, we use less energy, right? But scope 3 is not really directly in your hand, right? But with this greenhouse gas emission inventory, you need to be responsible for this one. And for this one, you need to optimize formulation, optimize all the manufacturing processes so that you can reduce the avoid the emission of the company, right? And this one is scope 1, scope 2, and scope 3. And the scope 4, some people call it like scope 4, will be the avoided emission. It means avoided emission will not in the scope or not directly in the responsibility of a company. It is more for other companies, right? But it will be something you need to think about that so that you can help the industry or you can help the market, right? That's why we have the term of scope 4 sometimes, but the more accurate way is to call it avoided emission. And we have a case study here for avoided emission when we have a typical concrete. I would say like admixture 1, when we use as the dosage of 0.1% in by weight around 700 or 800 millimeter per 100 kg of per 100 kg of cementitious material. And nowadays, all the concrete companies use the SCM like slag or fly ash, right? And then in this study, assume that people use about 20% of the slag or fly ash, like we could say it's a typical percentage of SCM. And then we have concrete, say around a grade of 40 megapascal. And then for the next solution, we have admixture number 2, very similar doses, very similar amount, and we can use higher SCM, up to around 60 or 70% of the slag of fly ash to replace the cement. And then everything else will be the same. And with this change or this solution, admixture number 2, the new solution is admixture number 2 will help us to use higher SCM percentage. The reason is if we use only admixture 1 and we cannot increase the percentage of SCM. When we have very high percentage of the SCM, the concrete will be like slump drop very fast, or the strength is not that high, and it's very sticky. And that's the reason why concrete company need to think about or want to have the solution for higher SCM, right? And with this solution, we can reduce around 35% of the global warming potential of the concrete from very high values here, around 300 something kg CO2 per cubic meter of concrete. Now we can reduce 35%. This is because of this solution. And of course, the global warming potential of admixtures still very small, but it can contribute very big reduction in the global warming potential of the concrete. Okay, let's wrap up some information here. Firstly, we can see that the concrete admixtures accounts only very small percentage in the concrete, but it plays a very crucial role in the modern concrete technology, right? And also, we can see that there is growing interest in the life cycle assessments of the admixtures, considering the total volume of the industry, and also the crucial role of the admixtures in the concrete. And the next thing we can see that published EPD with life cycle assessment study is not a simple job. It's very complicated job. But although it's very complicated, publishing it is very essential to measure the emission of the products and also promote the transparency in the construction industry. Next thing we can see that specific EPDs of admixtures produced in Australia provide essential data for concrete manufacturers. After we have the EPDs for admixtures in Australia, the concrete supplies here don't need to use the results from Europe, right? And product formulation is the key factor in the environment impact of admixtures. That's why the admixtures manufacturer need to like work hard to optimize it so that you can reduce the environmental impact of the product, but maintain the performance of the product. And then last one, but not least, is the avoided emission. This term is very important one in the sustainability topic because this one is when the companies try to solve the solution of other companies or the industry, right? And the avoided emission will fall outside the emission inventory of the manufacturer, but it's very important, right? Yeah, okay, this is the end of my presentation today for concrete admixtures. Thank you for your attention. Kumo,
Thank you so much.
do you have any Q&A?
Yeah, there's actually quite a few questions that we can go through. So
yeah,
let's just see what our attendees had to say. So the first question is from Louis Lopez, and
yeah.
he is asking, what are the main criteria for defining scenario 1 reference and scenario 2 with the new solution, and how do these definitions influence the calculation of avoided emissions? That's a question from Louis Lopez.
Yeah, okay. Thank you very much for your question, Luis and Humo, for explaining it. Let me go back to this avoided emission. Yeah, avoided emission. Scenario 1 is something like the typical one. It means like in my example or my case study, we have typical misdesign now with the concrete company is they just use around 20% of the slag or fly ash. This is very typical, right? And with that typical misdesign, they have all the we have all the other raw materials, and we can calculate the emission of the total concrete based on the misdesign. And with the new solution, we have something new because typically people cannot use very high slag percentage. They only can use 20 or maybe try a little bit more for 30 or 40%, but 60 or 70% is something like impossible because of the barriers like the workability, the strength, right? And this is when we have the new solution, when we have new admixtures, when we introduce it, and we can use higher percentage. This is new. Okay.
Thank you so much.
Yeah,
Oh,
it's clear.
yeah. So the next question we've got is from Mulenda Eli, Katanga CD. So the question from Mulenda is, what is the function of an accelerator in concrete? And under what conditions or concrete types might it use present disadvantages or limitations?
Okay, for the accelerating admixtures, that one is help to let me go back to the slide. Here, right? Accelerating admixture is basically it reduces the set time of the concrete. It means typically maybe we need to have 5 hours, 6 hours to concrete to like set or harden, right? But set time will make it faster. Right? For example, around 3 or 4 hours, it can set. It means you can reduce the waiting time so that you can have earlier strength of the concrete or shorter time of the shorter waiting time, right? And the second part of this question is
the second part is, and under what conditions or concrete types might it use present disadvantages or limitations?
Okay. use present disadvantage. Okay, disadvantage and limitation. I guess this one's for the accelerator, right? Yes, it can have some disadvantages. Yes, to be honest, you have disadvantage and you can satisfy the other thing, right? For example, if typically when you have the accelerator and then the final strength typically is a bit lower than the typical one, right? For example, if that country we have like 40 MPa at 28 days, but when you use accelerator, it can be slightly less, like 38, 39 or something, right? 39 point something, right? This is the first one. The second one is if like in the hot weather and you also use the accelerator, the hydration occurs very fast and it can have some problems with cracking or kind of that thing, right? That's why if we need to consider properly like whether we really need accelerating for like to push it happen faster. Yeah, hope it's clear for you. Thank you for your question, Linda.
Thank you so much, Dr. Namli. And then the next question, Louis Lopez, we've answered one of your questions, so we're just going to go quickly to Bellarmino and just answer that question about the use of admixtures. The use of admixtures can influence on the economy of a small construction. How can it impact in a small construction? So I'm guessing
Okay.
I'm guessing the question is about the influence on the economy of the admixtures for small constructions.
Yeah, okay. Yeah, I think nowadays admixtures is not only used in the last project or last site. It can be like small site. I think like people can produce like small can make can build a house or kind of thing. They can also use concrete. Without admixtures, we still have the concrete. Of course, we have concrete for 100 years or something. But with admixtures, of course, we can improve the properties of the concrete. Can have higher strength. We can have like less cracking issue, and then that case we can use admixtures. I think the whether the project or the site is large or small, it doesn't affect much whether we can use admixtures or not. But of course, like small projects, we may need something like different packaging so that we can adapt this requirement.
Thank you so much. And then I think
Yeah,
we've
thank
got
you.
time for 2 or 3 more questions. So
Yeah.
the next question is from Tony, and Tony is asking, are there standardized LCA tools or databases specifically for concrete admixtures, or is data often estimated?
Yeah, okay. Thank you for your question. It's a very good one. Thank you, Tony. Yeah, the database for the LCA in general is like the generic one. The generic one, but they need to update it or they need to revise it, to review it like properly around every year annually, right? And this database will be managed by some specialists in the like the companies who responsible for life cycle assessment, not from user like concrete admixtures manufacturer. And these specialists will ensure that the database is like accurate, right? The next thing is for are they specifically for concrete admixtures? Yes and no. Some companies they have like very general tool or software to calculate the life cycle assessment of admixtures. But like here in Sika, Australia, we used like a specific tool designed for the concrete admixture so that it can use all the data is very specific for concrete admixtures, and that's one also we have some like automation so that it can reduce the modeling processes. Yeah.
Thank you so much. So I think we could only have one more question. That's how much
Yeah,
time allows us. So
yeah.
we'll take one from Morobe Walter Tiroyayona. And his question is, in order to ensure that two EPDs from different programs can be reliably compared, what specific checks should be done given differences in PCRs, background data, and regional assumptions?
Yeah, thank you, Morobe. I think Morobe has a good background for the life cycle assessment. Yes, in order to compare the two EPDs, as you mentioned, we need to have like comparable program or PCR, right? And also, of course, as I mentioned earlier, we need to have they need to follow very the same standard like EN 14. 04078 and also the country, of course, like the background data and the regional assumption, they can be something we need to consider, right? It means that when we have two EPDs, it's not easy to say that, okay, this one is better or worse than the other one. But this one, in the reality is people also need to think about that. People need also have the feeling that, okay, we need to compare because this value is too lower than the other one. And then okay, this lower value can have some benefit, right? But as I mentioned also, the performance is also something very important to consider when we consider two products, not only the global warming potential or other environmental impacts, but the performance, right? If you can use lower or higher doses, it can affect a lot to the emission within the country. Yeah, thank you again for your question.
Okay, so that should wrap up our Q&A session as we are out of time. Dr. Namli, thank you so
Yeah,
much for
thank
providing
you.
us with your expertise in this topic. And I would just like to highlight a few things just before we wrap this up. And one of which is we need to, number one, thank you all for attending our webinar today. And so basically, based from today's topic, these are the courses that we offer here at EIT. And you can feel free to reach out to us on our website or book a call with one of our course advisors if you are interested in any one of these following courses that we're offering, which are related to concrete admixtures and so forth. And the upcoming courses for later on this year and early next year are up here on the screen. You can take a look at that. And I have just posted right now the links. So we've got the links for the certificate of attendance, but you will have to fill out a form in order to receive the certificate of attendance. And then you can register for our upcoming webinars. We've got the link there, as well as if you'd like to speak to one of our course advisors with regards to any courses you may be interested in, then we've got the link there. And then the course schedule is basically a link that shows you all the courses we offer. And then, yeah, thank you all for coming through. So as you can see on the screen, there is a link and a QR code for the certificate of attendance. So like I had mentioned earlier on, you will be sent a copy of the slide and the recording for this webinar today. And we've done our Q&A, so thank you all for you that have posed questions to Dr. Namli. He did a good job at answering those questions, and you guys did ask some very good questions. So these are contact details, and thank you all once again for joining our webinar today. Have a good day or good evening, or have a good morning, depending on wherever you are in the world. Thank you so much. Have a good day. Bye.
Thank you. Bye bye, everyone.